Have you ever wanted to set up authentication in Spring Boot without dealing with database? Maybe you are testing a feature or learning Spring security and you just need a quick and easy way to manage users. In this video, I'll show you how to use InMemoryUserDetailsManager to authenticate users in Spring Boot without any database setup. We'll go step by step from project setup to defining custom users and handling authentication errors. By the end, you'll have a solid understanding of how in-memory authentication works and when to use it. So, let's get started. Let's start from scratch. I'm going to create a new Spring Boot project. For this, I'll use my favorite online tool. Go to start.spring.io. From here, we can configure, add necessary dependencies, and generate our Spring Boot app. I am choosing Maven as the project type. Then, choosing Java as the programming language. Now, choose the Spring Boot version. At the time of this recording, the latest version of the Spring Boot is 3.4.3. This version number may be different depending on when you are watching this video. Now, it's time to configure the metadata. First, I need to provide a group name. This is basically the domain name in reverse order. Mine is com.learnwithiftekhar. Then give the artifact name InMemoryAuthDemo. Now giving it a short description. In-memory authentication demo. Then for packaging, I am choosing jar, and for the Java version, it's 21. Now it's time to add the necessary dependencies. Click on this Add Dependency button, or you can use the shortcut Command+B if you are using Mac or Ctrl+B if you are using Windows or Linux. Clicking this button will open the modal window with the list of available dependencies. The first dependency I need is Spring Security. Then we need Spring Web, as I will expose some HTTP endpoints. That's all the dependencies we need right now. Click on the Generate button to generate the project. Our Spring Boot project is generated and downloaded as zip file. Now open the project in your IDE. Here, I have opened my project in IntelliJ IDEA. You can choose whatever IDE you like. Before diving into the coding, let's make some time to explore the files and folder of the project. The first file I am going to explore is pom.xml. POM stands for Project Object Model. This is an XML file that holds the information of the project. Here, you can see the project metadata that we have defined. And also, let's scroll down. Here, we have the Java version of the project defined. And below, we have the list of dependencies. This one is Spring Security, and this one is Spring Web. We also have additional dependencies included. These are included automatically by the initializer. Those are test dependencies like starter test and security test. Next, let's open the sidebar. Here, we have this SRC directory. This is where all the application logic, configurations, and resources are stored. Inside SRC, we have two main directories, main and test. This test directory is dedicated to writing test. This folder contains test classes to write unit test and integration test using JUnit and Spring Test. The main directory contains the actual application code and supporting resources. It has two key subdirectories, Java and resources. Resources folder holds all the configuration files, static resource, and templates. The key files inside this resources directory is application.properties file. This is where you configure database connections, server settings, and other properties. Here, in this Java directory, inside src main Java, you will find the base package of your application. This package contains the main class. For our application, it is named InMemoryAuthDemo.java. Let's open this class. Here, you can see this class contains the main method. Currently, it is showing error. That is because our Maven project dependencies is not loaded properly. Let's open this Maven tool, select our project, click on this refresh icon, reload all Maven projects. You can see it is resolving the dependencies. Let's wait for a couple of seconds. So, our Maven dependencies are resolved and the project is loaded properly. Here, you can see we do not have any error. Now, let's run the project. There are a couple of options for running the project. First, we can click on this play icon beside the main method. Here, there is another play icon showing beside the class name. We can also use this to run the project. We can also right click, then Choose this run to start the project. What I am going to do is that I am going to use this play icon at the top to run the project. This I think this is the most convenient way to run the project in IntelliJ IDEA. Let's run it. Our project is started. Expanding the console a little bit. Here in the console you can see the message Tomcat started on port 8080. Scroll up a little bit. Here Spring Security has generated a random password for us. We can use this password to log into our application. Let's try to log in. Copy this password, open the browser, navigating to our project URL. Here we have this login form. I am going to log into the application using default username and generated password. The default username is user and paste the password. Sign in. The login was successful, but we see a white label error page instead of a proper response. This happens because we have not defined any resources to handle this endpoint yet. Let's do it now. Inside the base package, creating a new Java class, Home Controller. Annotate this with REST controller to define it as a REST resource. Now we need to define an endpoint and create a method to handle incoming HTTP request for that endpoint. It will handle GET request. So GET mapping. Provide the endpoint. This is root. Then public method that returns string response. It returns string message hello world. Now start the project. Spring has generated another password. Let's copy it. Back to the browser, refresh, provide the username and paste the password. Sign in. Here you can see the response from our controller. Let's log out for the time being. Log out. Up until now, we have not added any custom security configurations. We have mainly used Spring Security default setup just to confirm that the necessary dependencies are in place. Right now, every time we start the project, Spring Security generates a random password. We can use this password to log in, but we don't have control over the username and password. This setup is great for getting started. Now, I will show you how to define your own username and password that you can use in your application. We will use in-memory storage to save user details. This means Spring Security will store the credentials in memory and use them to authenticate users without needing a database. Just like the default setup, InMemoryUserDetailsManager is not made for production, but it's an excellent tool for learning and testing. There are cases when you need a quick Spring Security setup to test certain features. You can easily use this. Let's start by creating a configuration class. First, in the root package, I am going to create a new Java class called SecurityConfig. Collapsing the sidebar for now to focus on the code. Here, we need to annotate the class with configuration to let Spring know that this is our configuration class. We also need to enable web security. So, we will use the enable web security annotation. In this class, we will override Spring Security's default configuration and provide our own. Now, we will define our user. Spring Security uses UserDetailsService to load user-specific data. So, we need to define a bean for it. Create a public method that returns InMemoryUserDetailsManager. Inside this method, we will define our user. Spring Security uses UserDetails object to represent users. I will create a variable named user equals. Let's import this UserDetails class. Here, define our user. User. Make sure you import user from the Spring Security core package. If you check the source of this user class, this class implements this user details. Closing the tab, we will set the username to Iftikhar and provide a dummy password. Next, we need to assign a role to this user. Roles are essential when we deal with the authorization. We are not dealing with roles in this tutorial. For now, we will assign an arbitrary role. Let's say admin and Bill. Finally, we will return a new instance of InMemoryUserDetailsManager and pass the user as constructor parameter. Then we need another bean for customizing Spring Security. Public method that returns security filter chain. This method accepts HTTP security. This returns http.bill. Before returning, we will provide some customization logic. HTTP. First, we configure HTTP request authorization. We will use a lambda DSL inside the authorize HTTP request method to define access rules. Here, I am defining any request that needs to be authenticated. And then we need to tell that we want form login. I am going with the default setting for the form. Now start the project. Back to the browser. Provide the username that we have defined and password. Sign in. Nothing happens here. Let's check if we have any errors. Here in the console, we have these error. There is no default password encoder. Each password must have a password encoding prefix. What does it mean? Right now, we are providing the password as plain text. However, Spring Security requires password to be encoded. If we don't use an encoder, the password won't work. To handle this, we could define a bean for the password encoder, but instead, I will use a simple approach. Before the actual password, I will add a prefix that specifies the password encoding type. Spring Security will automatically recognize the prefix and use the appropriate encoding strategy. To do this, we wrap the prefix inside a curly braces. Since I am using a plain text for now, the prefix will be no op, which tells Spring Security that no encoding is applied. Now start the project. Refresh the browser, provide the username and password. Sign in. And there we go. We have successfully logged in and we can see the response from the controller we have defined earlier. So, in this tutorial, I demonstrated how to use InMemoryUserDetailsManager to manage user authentication in Spring Security. With this approach, we stored user credentials in memory, allowing Spring Security to authenticate requests without needing a database. While this method is great for learning and testing, it is not suitable for production environment. In real-world application, you should use a more secure approach like a database-based authentication provider. If you want to explore more about Spring Security, including database authentication, JWT-based authentication, and role-based access control, check out my other video tutorials. Make sure to like, subscribe, and hit the notification bell so you don't miss future Spring Security lessons. Thanks for watching, and I'll see you in the next one.